All right. Welcome everyone to the 11th ROS2 Hardware Acceleration Working Group meeting. Let's get started today because we have quite a few topics to cover. My intention today is to have maybe longer than the usual discussion at the end. So we typically discuss a number of topics and then we have a long Q&A at the end. We're going to give that a try this time. We don't have this time a guest speaker. So hopefully there will be lots of questions and thoughts and topics that we can discuss. And if not, we'll close sooner this time. For those of you arriving right now, I'm going to paste once again a link to the minutes. Sorry, lots of people entering. And let's get started. So with this, I'm going to share my screen. All right. Okay, there we go. Okay, so hopefully now everyone can see my screen. Can someone confirm once it's visible?
I can see it.
Cool, thank you guys. All right, so let's kick it off. As I was saying, welcome everyone. This is the 11th meeting. We've been running for a while. The last meeting was before the summer. We had a long break. I hope everyone enjoyed it. We certainly did on this side. Very needed and very refreshing. So let's continue with this series of meetings about hardware acceleration in ROS2 and robotics, which, as some of you know already, essentially aim to ensure that we do provide accelerators for ROS2 and Gazebo, and that is covered within the mission, goal, and vision of this working group, which I'll be refreshing in just a bit. So typically the way we proceed with these meetings is we start with an official welcome and we do a series of introductions, but I'm afraid this time we're going to have lots of new people to the working group. I think there are more than 350 folks that said they were participating. I don't know which one is going to join. So we're going to try something new this time. You can check the whole participation list in the event if that's something you're interested. And for those of you who are new to the working group, I would kindly ask you to just perform a self-introduction in here. So you can go ahead and edit this document. Again, if there's someone missing a link to this, ask for it. Everyone should get access to the minutes. And please just add a line in here. If you're new to the working group, just saying a few words, name, of course, where you work, and how are you related to hardware acceleration, whether you're using FPGAs or GPUs, and what is your interest in that line. So I'll let you guys do that in the background while we proceed with the meeting. And with that, I think we can get started with the first official topic of the All Business and Administration section. Some of you have been exposed to the concept of the Robotic Processing Unit, which we introduced a few meetings ago, and we've been discussing and updating meeting after meeting. In a nutshell, the objective of this project, which was a sub-project of the working group, was to essentially bring up a robotic-specific processing unit that mapped ROS and robot computational graphs efficiently to underlying accelerators, including CPUs, FPGAs, and GPUs. We've been doing lots of prototyping on this regard. There's been benchmarking efforts. There's been lots of private discussions among a subset of you. And with all of that, essentially, we reached a point wherein we had an initial version to propose as a reference hardware platform to start further working on optimizing computational graphs. And I'm super, super happy and pleased to share that, as introduced in here at the beginning of this project, we always wanted to have this meta ticket as a, let's say, temporary aspect. And eventually we were hoping to branch out into its own repository. And that's exactly what has happened. I'm really happy to share that right now the Robotic Processing Unit, and I'm sharing a link in the chat, has its own repo. This repo, again, echoes the objective of this particular subproject of the working group, and it shows like the package of it all composed. In particular, the current proposal of the Robotic Processing Unit is a sandwich composed by CPUs, FPGAs, and GPUs coming from two leading vendors of semiconductors, AMD and NVIDIA. The project essentially has been sponsored by my organization, and there's a bunch of articles that are being written about it, which we will include in here over the coming few days. But in a nutshell, we believe we did accomplish the initial goal, given the data we have and the benchmarks we've been producing so far. And we look forward to see what people's going to be building with this and what we also will be releasing on this regard. There are complete instructions on how to build your own robotic processing unit, which is what we also wanted to have early on the project so that people can prototype on their end. If you're researching with hardware acceleration on your organization, we wanted you to also have a piece of hardware that's similar or identical to the ones the community members out there are using to build accelerated computational graphs. And we also wanted to make sure that we were representing appropriately the interests of those of you with playing with acceleration out there. So we wanted to have at least representation of CPUs, GPUs, and FPGAs, which seem to be the main contenders and the main ones asked. And I'll dive into that in just a bit because we will be touching on the survey results, which we conducted about a year ago. But as I was saying, the bill of materials has been disclosed. Actually, all of the design files have been disclosed. The 3D parts that put together the exoskeleton, the outer exoskeleton of the cube, can be essentially accessed in here. And I think GitHub gives you a visualization. So this is the base, and there's also the cover, which goes on top. And then for each one of the boards that gets attached, there is its corresponding adapter. So you can check it out there. And then we're using commercial off-the-shelf elements. As promised at the very beginning, we didn't want it to come up with a new piece of essentially semiconductor line of technologies. We just wanted to reuse off-the-shelf technologies and compose it, combine it in the right form to ensure that we get best performance from a ROS perspective. There are some additional pieces of electronics which are used and which essentially bridge the gap of the necessary power electronics to power both boards and ensure optimal use, but pretty much it's a really simple bill of materials. And there's also some assembly instructions, which we've attempted to make them as simple as possible. So there it goes. And I'm very much looking forward to see people out there building their own robotic processing units. Please send pictures if you do engage into building one, and definitely looking forward to discuss this more and more over the following few working group meetings we will be using very actively. And also aligned to that, just quickly mentioning, as you know, we do keep in the working group a community repo, which essentially provides the community governance model and the list of projects and sub-projects that we are working on. We also keep a series of objectives and goals achieved or work in progress. And as part of that, we've also extended the section on reference hardware platforms to include this robotic processing unit. There is already access to the firmware layer, and you can reach out if you want early access. We're still touching the final bits on it, but we think that it's pretty much ready for people to start testing. So that's the first piece, which to me personally and to my team in Acceleration Robotics is very exciting, especially because we have been using this piece of hardware for quite a while. Actually, I should show you. So this is one of the prototypes I have with me. As you can see, I mean, the box itself is not the average Raspberry Pi size. It's slightly smaller. Actually, there was a community member comparing it with the Raspberry Pi SBC, which is, by the way, fantastic, and I've used it plenty of times, but it's a different piece of technology, probably thought for a, let's say, a different set of robotic applications. So that's going to continue that discussion in ROS discourse, but just wanted to emphasize that we are super excited. And also as part of that excitement, also wanted to mention the fact that we are releasing this. We have open sourced the design of both, and we will do so firmware and hardware. But also wanted to emphasize that we don't want the project to fall apart. So as part of that commitment, we wanted to make sure that those of you using this for professional and industrial use cases, we want you to feel supported. And that is why we are launching commercial support around this robotic processing unit, including, of course, documentation, support, but also access to tools and accelerators, which are custom built to accelerate ROS to compatible libraries. And also, besides that, we also offer a ruggedized version of Robot Core, and that is in this section. So that ruggedized version is presented on our website with a fancy video and so on and so forth. But I just wanted to highlight the fact that the same technology is the one that you will find in the Robotic Processing Unit, the exact design files that we use. It is just that we are using different material, but you can 3D print this still yourself with plastic, PLA, which is the most common one. We are not using PLA nor plastic for the ruggedized version. And certainly with it also comes the corresponding support and the corresponding tooling that we do offer as part of the, again, commitment we want to offer to get this project as far as we can. So that is one fantastic piece of work we think we wanted to show you, and something we are very proud of, and which we, again, look forward to featuring upcoming works. Now, that is very connected to the second topic of today's agenda, which is the survey. So as some of you know, we have been conducting surveys, well, actually one survey, but we insisted a few times over the previous, I would say, months to have the community answer. We have a preliminary version that is pretty much ready to show. And thank you, by the way, to those of you that I contacted privately and that offered feedback so far. That is very much appreciated. I would encourage those same ones to keep up with the reviews if they are still interested. And I also wanted to open it up for new reviewers. So at this point, we're looking for maybe the last batch of reviewers before this comes out. I just wanted to give you a sneak peek today of what it is, how does it look, and what is essentially going to be putting together. So again, there's a description about the fact that we have the strong belief that hardware acceleration can change the landscape of robotics overall, and of course of ROS2, how hardware acceleration can bring ROS to the next level by essentially accelerating, speeding up robotics computations and thereby robots overall in real life, also making them more secure and safe in their corresponding behaviors. And this working group focuses specifically on that. So it is our commitment to try to conduct this survey at least once per year. We'll do our best. No huge promises, but it sounds like something we should be doing based on the results we have obtained. Not only to capture the opinion of the community, but also the state of the art in terms of performance performed or benchmarked in a quantitative manner. And so the report itself has about 60 pages. Yeah, we went too far, I think, but it is summarized in a I think 3 pages or 4-page executive summary, which you can read also, and which includes the main highlights. So yeah, it starts with that, the executive summary, which again brings you up to speed about the relevance, why we're doing what we are doing, and essentially how this report aims to capture the state of the art. We also, as part of this executive summary, sorry guys, just one sec. I'm gonna close this. Hola. Baby enter the house. Okay. So yeah. As I was saying, so the report does conduct this survey, and it reports on the corresponding numbers, and you should expect lots of very, very interesting results. One of the ones that I love is the fact that, as we've been doing, and some of you have been following up with us for the last few months, we've been doing lots of performance benchmarking on perception. And you might be wondering, well, why have you guys focused so much on that? Well, because 64% of the respondents actually said perception was the most important thing for them. So we really were playing by the data. But unsurprisingly, there's also lots of interest. And by the way, this was a multi-selection allowed answer or question. So there was lots of interest for Gazebo, lots of reasonable high interest for navigation. And then there were some surprises. I was expecting manipulation movie to be much higher, but it seems that, for example, hardware accelerating DDS, the ROS2 communication middleware, was one of the big asks. And also connected to that, the fact that people really want further acceleration on the networking stack for various reasons, and that's something we will touch on in future meetings in the following semester. But nevertheless, very interesting. There's lots of super interesting data about what is the requested root file system, how things should be packaged, and lots of data that you'll get access to. Besides that, we also conduct quantitative benchmarking by following community standards, so to speak. And that does throw some interesting data, which also will be available, displayed, summarized, and reported. Again, that is just the executive summary. Just to don't leave you only with that, I'll just scroll quickly through it. But unfortunately, it is too long to cover it in this short meeting. But anyhow, there's a long introduction justifying why hardware acceleration is relevant. There's also an interesting section which does argue about the fact that performance benchmarking in robotics needs to consider both latency as well as bandwidth aspects. And this is crucial because we are increasingly seeing how many performance benchmarking reports coming from certain vendors of semiconductors just focus on bandwidth. And this is a mistake in our opinion, because robots are all about determinism in real time. Robotics or robots are deterministic machines overall. So getting the right timing is one of the most important features, and certainly hardware acceleration should be mindful of that and should be captured as part of a proper benchmark. So that is something that that we have been discussing, that you will find here discussed as part of that intro. Then there's plenty of data about the community survey. Again, I was scrolling super fast, but for each one of these questions, you will see a detailed set of answers. And as I said, there is really, really exciting data in here. So I'll leave you with that. After all of these community surveys, we will then also disclose a bit about the benchmarks, the quantitative benchmarks we did conducted. So we first present the case study that has been analyzed, and then start reporting on the different data. And again, apologies for going fast, but I encourage you to contact and be one of the reviewers. We would really appreciate that. And by the way, one thing I should mention is that the benchmarking happens in both computational graphs, so at the graph level as well as a node level, because it is not just important to get computations super fast, but also consider the network effects that happen in ROS2, which also is a topic we've been discussing for quite a bit. Then the last section pretty much provides a discussion. Actually, I think it's the previous to the last one, which just summarizes the results and tries to draw some conclusions. So I'll leave it there. Again, if you are willing to put an hour of your time into reviewing this, contact there, and I'll be happy to speak with you about how we can make you a reviewer. Fantastic. So with that, and again, please just stop me if anyone has a question. I think we do have plenty of time today, but I'll give you a sneak peek about the REP 2008 updates. And for those of you new to the working group, REP 2008 has been, so actually I should probably give you a bit of context about REPs, especially for those of you not that experienced in ROS. So REPs, or ROS enhancement proposals, are essentially the way that the ROS community and the ROS ecosystem overall gets standardized. So there's a bunch of essentially standards in a way that get written in this form. Some of them cover how essentially coordinates should be defined for specific robotic systems. Some others define what are the security policies that are recommended within the community. Some others describe new capabilities such as type adaptation or type negotiation, and so on and so forth. Others describe and argue about how ROS gets released for new releases, what are the official targeted platforms. So we've been working on a new standard, REP 2008, which essentially tries to, in a way, provide a series of conventions and a reference architecture for what concerns developing hardware acceleration. Now, this is nothing new, and there's quite a few folks that have reviewed. Thank you, because many of those are part of this group. So thank you to all those of you who expressed their support or concerns as well. I think that is fantastic, and I'm very thankful. This started quite a while ago, and it has now reached a decent stage of maturity, to the point that this was presented a few weeks ago to the ROS2 Technical Steering Committee, which, as you may know, is the committee that's driving the development of ROS2, composed by Open Robotics as well as a group of companies which are relevant in the robotics industry. So the feedback provided by the TSC was, I would say, overall rather positive. There was lots of excitement about this work surrounding hardware acceleration and this REP 2008. There were also some concerns, of course, especially around the fact that they did acknowledge that hardware acceleration is a very complex topic, very new to lots of people, even some present in the TSC, they acknowledged it. So the main asks that we got as part of this group trying to push forward the REP 2008 was that they wanted essentially to remove the complexity on how to categorize the different accelerators, which corresponds with this section in the REP that, and let me give you a visual intuition about that. So the REP does specify a series of categories. It classifies hardware accelerators based on how good they can comply with the different needs that are required to have a good experience with hardware acceleration. So in principle, this is how we were classifying and proposing to classify the different accelerators. They did not dislike it, but I think the ask was to try to remove the complexity, and with this, the overall issues that this brought together. So that's one thing that will be addressed. The second one is the benchmarking effort was certainly acknowledged and very needed. However, it overall felt too complicated for some reviewers within the TSC. So they also asked for that to be moved into a new REP. And so there's an ongoing effort right now, which started a few days ago, and I just pushed or made a gentle push this afternoon. This is a draft. And it's going to be a new REP, which is going to discuss how benchmarking should be performed in ROS2 systems. So if you're interested in participating in standardization efforts, which, by the way, is great for students, but also for industry members, this is a great opportunity right now. This work is just getting started, and you have the chance to not only place your name in there, but also have the opportunity to influence it. So I would encourage everyone to dive in and express their support or interest to participate. So that is something that's going to also be arranged, removing benchmarking from the existing REP 2008. And finally, just some minor changes on the repositories, whereas when instead of using acceleration, we'll be specifying hardware acceleration. And I think that's a very valid ask that we will also change. Finally, I will try to rephrase the current motivation to try to make it a bit more simple. I already advised that's going to be challenging because I am very contaminated. I've done lots of iterations, so I do need some help to try to further help people digest this. I'm very biased, that's the word. But I'll do my best. So this is what's going to happen in REP 2008. In the approximately following week, I will be doing these changes. Those of you tuned to hardware acceleration, encouraging you to participate again in REP 2008 and now in REP 2014. And yeah, hopefully this is going to receive a pass from the TSC. I believe that the official vote is going to be happening at some point in ROSCon, which, as you may know, it's happening kind of like late October, so in a few weeks. So yeah, I did take the commitment to get this ready for the final review and for the final vote. So crossing fingers and hoping that this gets a pass. All right, moving now into progress review and new business. So, and this is going to be super quick. I just wanted to bring to your attention the fact that so the working group is growing, as you can see. The amount of feedback and messages that we're getting is increasing significantly, but fortunately also the amount of results we are producing as well as impact. So we've been invited to a number of workshops and conferences, which we will consider participating. But immediately what you should be paying attention to are these two events, which are happening in the following few weeks. So if you have the chance to fly to Japan, Kyoto, or if you will be around, I encourage you to participate in ROSCon and IROS, especially in ROSCon. There will be a 20-minute talk about hardware acceleration. Actually, the only hardware acceleration talk is going to be given by ourselves, by the by representatives of the hardware acceleration working group, and it will be given essentially the 21st in the afternoon, Japan's time. So encouraging you all to take a look at it. For those of you who have sticked around for a while, you may not be hearing super new things, but still we will be trying to disclose some new stuff as part of that talk, which will raise the excitement. The second one is more academic, and it's given within the context of IROS. And I'm giving this talk with Sabrina, Brian, and BJ from Harvard and MIT. So essentially well-surrounded, certainly. And it'll be given a few days after that, focusing again on the more researchy side of things, speaking about frameworks in the robotics context. So also encouraging you to check that out. I'll be in person there in both events. I'll be also showcasing and featuring the Robotic Processing Unit, or robot core in this case. And yeah, it is a great opportunity to shake hands and get to know each other. So if you're around, please just drop me a line, and we'll chat. And with that, let's dive into one topic that I'm super excited about, which is brand new. And also we have Max from Plan B as a guest today, who hopefully will tell us a few things, or at least essentially what are his thoughts about the project. So officially speaking, Acceleration Robotics, which is the organization I represent, together with Plan B, which is the organization Max represents, have reached a partnership to bring forward or push forward a new project that we are initially going publicly with Robotics MCU, or microcontroller unit. The technical name is going to change. It was originally roscore-v, but there's been some community feedback against it. So I believe that we're going to go with a different thing, particularly with Robo 5 MCU. We're going to go with that for the project's technical name. In a nutshell, the project itself aims to combine two pieces of open source and hardware technology, which I think all of us are very excited about, which are the RISC-V instruction set architecture, as well as the ROS2 communication framework, robotics framework overall for robotics. The project itself has been defined and described in this ticket, which you have linked and available in the board of the community. In a nutshell, you have the definition there, the rationale, which I will not get into. Actually, sorry, yes, I should probably say a few words about this. And then, the project is open for sponsorship. So especially if you are building technology that is similar or interested in this line of work, or if you want us to prototype this Robotics MCU in your FPGAs, then please reach out and we'll find a way for you to support us. And we'll be using that technology to showcase it to the community. There are also some milestones proposed. Maybe what I'll do is I'll just say a few words about the rationale and why we think this is so important, and then maybe hand it to Max for him to share maybe a few more words on RISC-V. And just for context, Max is the super expert on RISC-V, whereas we come more from the ROS2 expertise side of things. So we're hoping to meet in the middle and together bring forward this microcontroller for robotics, or Robotics MCU. So in a nutshell, and to drive the discussion, the rationale in here is that most the use of microcontrollers with ROS2 today, to a huge extent, goes through a project called MicroROS. Some of you might have heard about it or might have used it. I was involved in this project. Actually, I was part of the consortia at the very beginning. I did help bring up the consortia and invite different members, and I was part of the definition of the architecture that then was implemented as part of the project. I'm very familiar with XRC DDS, and also I've used this extensively in real robotic applications, as well as benchmarked it. And in my opinion, the main drawback of this is the fact that it does present an architecture that breaks interoperability with ROS2 systems. And let me give you guys a visual intuition of what I mean by that. So hopefully this picture is going to help understanding. So we have two separate words. We have the word of ROS2, which is powered by DDS, essentially PubSub peer-to-peer communications in a common data bus with RTPS protocol. And then we have the MicroROS project, which is governed not by DDS, but by another OMG standard, which is XRC DDS, which is not PubSub, is client server, and essentially breaks completely the principles of DDS. So there is client server architecture on the microcontroller side, which then communicates with an entity that is living connected to DDS and generally running in a fully fledged CPU and ROS2 setup. And so this client server plus intermediary that then jumps and dives into DDS data bus and thereby ROS2 is what brings all sorts of technical issues when it comes to optimizing performance, obtaining determinism, and also achieving certain objectives within real time. So that is a bit of the motivation. And what this project tries to do is to break a bit this gap and to propose a microcontroller that does not need to leverage XRC DDS, but that can speak to DDS directly, or more specifically to ROS2 by having DDS capabilities. That is, in a nutshell, the initial objective. There are 4 kind of like milestones we have drafted together with Max and his team. And in a nutshell, these 4 milestones is we will first try to start by leveraging an open hardware, an open source and hardware RISC-V based MCU design and build on top of it to achieve ROS2 direct interoperability. That's going to be the first milestone. Once we achieve that, we will benchmark that against existing ROS2 solutions for enabling microcontrollers, namely micro-ROS. And we will do so by running micro-ROS in soft cores as well as in hard cores. So essentially, we will run micro-ROS in physical chips as well as in soft cores synthesized in an FPGA. And we, for our development, will be using FPGAs for iteratively improving the Robotics MCU. So that's how we will be working and how we will be translating our RISC-V design into something that we can benchmark and test, and that's why the soft core reference is in there. So again, benchmarks are phase or milestone 2. Milestone 3, once we do achieve like decent numbers and we do have high expectations on that end, then that's going to be the first, let's say, only the first step. We want to go further. We do know that we can bring pieces of that RISC-V based, let's say, stack that we will put together that achieves ROS2 direct interoperability. But we believe we can bring some of those software layers that we'll be using into essentially into IP blocks. And these IP blocks can then be transformed into hardware. And this is going to further improve the capabilities, further provide additional determinism, and thereby some additional real-time capabilities. So this will be what we will tackle, and we will do so in spirals in milestone 3. It is too early still to advance which specific layers and at which level, but there's been some questions around if we were going to be looking into the networking stack, if we were going to be using UDP. Shortly, yes, we will look into the networking stack and bring that as part of essentially what we can bring to IP blocks. We will be using UDP, namely because RTPS builds on top of UDP. There's also capabilities and DDS implementations that rely on TCP, but we will not look into that. We will be relying on UDP. And I think that's pretty much it, what I've heard questions-wise so far. Milestone 4. So once we do achieve essentially this capability of bringing, again, the initial design plus maybe some additional layers as IP blocks, we will then start looking at customizations of the instruction set to further optimize ROS2 operations. So most, and this is also one of the pitches we are making in here, most of the MCUs have rather general purpose blocks. And they don't have anything robotics specific, even if used in robotics. We just think that there's things we can do to further improve that, even maybe some tiny, small accelerators that can help drive ROS2 interactions in a more, let's say, deterministic manner. And that is what we will be looking at in milestone 4. Finally, provided we have completed everything and we are satisfied with the result, then we will look into bringing the soft core. Again, in every single one of these steps, we would be prototyping everything in an FPGA. But provided we reach that end wherein we are happy with the results, then we would look into bringing things into a hardcore, into a physical chip, if you wish, And for that, we will look into one of the right now super popular foundries, which are making prototypes with 22 nanometers or some with a higher dimension. But nevertheless, that's going to be not so relevant for us because we would be looking at just prototypes, plain prototypes. But that's pretty much the scope of the project. Of course, reaching milestone 5, if we reach it, it's going to take a while. For now, the partnership we've reached with Plan B and the objective of this initial kickoff is to go towards milestone 1. And the preliminary date we have set for ourselves, as well as tech capabilities, are described in this picture. So we are targeting May next year to have milestone 1 completed. And it is a good date because it aligns with the next ROS release. Iron is going to be released in May. So ideally, we would have achieved these capabilities by that date. Again, it's going to be driven by resources that we have, and anything anyone out there, you guys and others, can do to support the project is going to speed things up, accelerate it, and obviously get it with more resources. So again, reach out if you can or want to support the project in any way. Having said all of this, Max is with us from Plan B, so I just wanted to open the mic for him to maybe share a few words about RISC-V and his impressions there.
Okay, so good evening, everybody. Thank you, Victor, for the very nice introduction. And yeah, also from myself, I can only say that I'm very excited about this project. I think it is a very good opportunity to show the capabilities of RISC-V instruction set architecture and the open source implementation of this instruction set. I'm very excited to start, and I'm very looking forward to how these two words can start talking together. Reaching milestone 4 with the customization and acceleration of ROS2 nodes on hardware. It's a very challenging goal, but I think it's totally feasible. It will take a while, but it will bring something new to both communities, actually.
Yeah, well said. Yeah, and that is something Max and I are looking into, and we invite others to also participate in that discussion. There's lots of excitement, and also I think this is shared also with many others in the TSC and Open Robotics. RISC-V brings a huge amount of opportunities. Customization sounds like is the way forward for improving performance in future robotic applications. It is in a big way what we are doing in the Hardware Acceleration Working Group, creating custom accelerators for the different and various robotic tasks. In this case, instead of maybe tackling high-end CPUs, we're trying to focus on a well-identified need. Again, as I justified, bringing ROS to microcontrollers has historically been of huge interest for industry, especially for safety-related applications, but also many others. These small application-specific devices are of huge interest. So yeah, very excited about that. Again, encouraging people to work with us on this, to learn with us, because there's going to be lots of learning on many ends in here. And also it is going to be a cross-disciplinary project because we're mixing lots of things together and hoping that by, I don't know, I don't want to give an estimate date, but at some point we'll have a physical realization and would be a fantastic result, certainly very satisfactory. All right, so I'll leave it there, but of course questions are super welcome. I'll just say one last thing regarding today's topics, actually two, sorry. The first one is regarding this project, the Robotics MCU. So Max and I have discussed it, and the objective is going to be to fully disclose open source and open hardware, the results. However, in the process, while development is happening, we will not be doing things in the open for various reasons, but mostly speaking, because we want to keep ourselves concentrated without too much noise on essentially things that do not contribute directly to the success of the objectives. However, we're totally open for folks, groups to participate and collaborate. So if you have bandwidth, just reach out. will find a good fit for your skill set, capabilities within the project, and then you will be adding those resources into it. Only that, again, you will be hearing from this, probably from me and Max, who will be reporting about the status of the project, but we will be developing things essentially not in the open, just to make sure we keep ourselves concentrated. And the last thing is I wanted to bring everyone to this list. So arguably, ROS2 is becoming the de facto standard in robotics. To some of us who have been around for more than a decade now in the ROS2 ecosystem, this was clear many years ago. For many others, this wasn't. And there's still some voices which are widely critical towards the readiness of ROS2. The best way to confirm this in a way is to check out who out there in industry is using ROS2 for commercial purposes. So I started together with my colleagues at Acceleration Robotics compiling a list of companies which are using ROS2 for-profit companies. And I want to emphasize that ROS2 or any of its related tools for development to create products or to offer services. So those were kind of like the restrictions we imposed on ourselves. And we started, putting together a list, and soon we realized we were reaching the hundreds. So at some point we decided to open source it. That happened about a month ago, I believe. And right now this list has grown into more than 400 companies, which I think is significant, at the very least significant. So I just wanted to bring your attention to this list. Just contribute if you have some ideas. Don't be shy if you're using ROS in your company. I'm sure you can ask your management and find a way to at least share it. It's certainly going to be on your interest. Many companies are doing so. So yeah, just wanted to end with that. Last piece of refreshing news. Also, feel free to use this list as a sales pitch internally in your organization on why you should be putting more time into ROS and into hardware acceleration and ROS. Hopefully that is a helpful resource that you can leverage, and that is going to bring more bandwidth into the working group projects. So with that, I think we can jump into Q&A. Hopefully we'll have a long discussion today. We have 17 minutes today. So questions, comments? None. I can read the first one that I can see in the chat, just to get us warmed up. So from Sublam Nagla, what do you think the scope of hardware acceleration is in front of GPU acceleration? In near future, or I would say in robotics? Well, I'm not so sure, Sublam, what you mean by this. I mean, GPUs are technically speaking hardware accelerators. So if what you are asking is what are they going to be using or used for, sorry, which is what I'm understanding from your question, I can answer that across the whole robotic stack. So they will be used across various robotic, let's say, tasks, going all the way from sensing to perception to motion control to low-level actuation and down to actuation. There are capabilities and there's potential to use hardware acceleration not only in GPUs but across other accelerators also, such as FPGAs, to be accelerating computations in each one of these different blocks across the robotic stack. And the complexity itself of the architect, of those of you building up architectures, is selecting the right accelerator and the right piece of technology for each task. As we have been observing, it is not trivial at all to develop such a skill. Requires experience and also lots of know-how about the various frameworks for hardware acceleration across the different vendors. But certainly, I think the potential of accelerating computations is across the whole robotics stack. Okay. So anyone that would like to go for it? Jaswant. Feel free to interact directly. Otherwise, I'm reading questions from the chat. Okay, so I'm gonna take this one. Is ROS, ISAC ROS gems are the first hardware accelerated software stack. So after your project, this will be open source, as most ISAC ROS gems are closed source. Sorry, I don't really understand the question. Maybe you can clarify, Isan. But ISAC ROS gems were by far not the first hardware accelerated software stack in robotics. In fact, the use of hardware acceleration in robotics dates back way back to the first robots. Most industrial robots these days do have pieces of hardware acceleration on themselves. Specifically, FPGAs are widely used in them to accelerate many aspects of them. ISAC ROS gems were proposed a few years back, and they've increasingly been, let's say, developed. But it wasn't until NVIDIA really acknowledged the relevance of the ROS community that things started to warm up. So the gems kind of like project converged into ROS, and ROS is the way forward. Now, I think NVIDIA is doing a good job in trying to be more open. As some of you may know, NVIDIA is not the most popular tech company for their openness and open source contributions, but I think they're doing an effort in the ROS community, and also it's part of the work we at the working group are doing, monitoring that and ensuring that they do release things transparently and in a usable manner. There's, however, lots of things to improve. The current, let's say, value propositions are not fully open source, and you can notice this if you look closely at the existing portfolio of solutions. You will find lots of static libraries. You will find quite a bit of complexity in terms of trying to understand certain things. So there's lots of work to do. Not to say that there hasn't been good progress. I certainly acknowledge that on that side. Similar to that, from NVIDIA's perspective, there's fantastic open source initiatives going and coming from all the way to Xilinx, now AMD, to integrate their technologies and accelerators into the ROS ecosystem. So those two are definitely leading the path, but there is, as far as I know, many other vendors who are pushing very strongly to try to bring additional acceleration capabilities in connection with the ROS ecosystem. So I'll keep my eyes very open, and if you're looking for something to play around today, I'll look into either AMD or NVIDIA.
You're muted, Victor.
Okay, can you guys hear me now?
Yeah. Yep.
Awesome. Thank you, David. So Devan in here asks, is there a strategy yet for connecting this device to message broker from this device? And if so, do we know the resource requirements? Okay, Devan, I'm gonna need you to jump out and say a few more words about that.
So I'm assuming maybe as a microcontroller, this device may be able to communicate with an application processor on board, which may be running like fast DDS or something.
Okay, so so we still need to get into the implementation. It's still a bit early to answer you with full confidence, but I can guess that yes, that will be a capability we will explore. The soft core will be synthesized and placed and routed in the FPGA, and then there will be a chance to communicate that with the application processor running in the same SoC, provided that there are application processors. You could do the same with RTX or just pure FPGA technologies and just synthesize the soft core, and that's pretty much it. So that is going to be a possibility, but the main connection avenue we are foreseeing right now is Ethernet. So we will essentially leverage boards that have PHYs connected to the programmable logic, to the FPGA, and we will be essentially pushing the output of RTPS directly from the microcontroller into Ethernet, so that it can interoperate directly with general purpose ROS2 systems out there. That's going to be the development mechanism. Once that is validated and we have that kind of like confirmed, I don't see why we couldn't develop other transports for other than Ethernet ways. Maybe some serials. We'll see, and we'll look into it. But I think short term, we're looking for Ethernet, also running within the PL.
I'm just trying to make sure I understand. The Ethernet is certainly a desirable play, but looking to use that communication to then talk to the message broker that other nodes may be connected to.
So by the message broker, you mean the DDS network?
Right. Thank you.
Yeah. So well, I mean that is part of the DDS discovery process. So it is in principle, provided that you're using certain configuration that comes by default, discovery should come right out of the box. So what we're going to do is just have within the microcontroller, I don't want to say fully fledged, but reasonably capable DDS minimalistic implementation that is going to be able to also implement that part of the DDS spec, RTPS spec to be more specific, which is the discovery part of it. So it's just going to be part of the package, I guess.
Great, thank you.
Awesome, cool. All right, more questions? Okay, I'll take. Go ahead.
Hi guys. I mean, this is like a little offshoot, but I was wondering, like, are you planning for any modules for time synchronization, like having a PPS in or throwing a bunch of sync outs when you're like interfacing with multiple devices and multiple systems? Is there any plan for that? Or, I mean, this is my first meeting, so I don't know. I was just looking at the architecture diagram and then.
Yeah, no, that is a very valid question. So right now, time synchronization is not something that's in the short term, I would say, activities that the working group is kind of like engaging with. However, I can point you to the fact that I do know AMD is doing great work on time-sensitive communications, specifically something called TSN, or time-sensitive networking, which is also using sub-microsecond synchronization capabilities, which can be achieved in a distributed manner. So feel free to reach out or just look for it. Look for TSN. Look for AMD time-sensitive networking solutions. I personally think that has lots of potential, and we may engage with that in the near future. There's just no confirmed activity right now on that end.
Oh, that's cool. So what about the Ethernet? Does it support? I mean, are you planning for Ethernet with a PTP or like hardware timestamping?
Yeah, that is exactly what I was getting at. So PTP is great, but only if you have an Ethernet, let's say, stack that is time sensitive. And actually, TSN is a series of standards that extend Ethernet for achieving time sensitive communications, building on top of PPT.
Oh, so that's great.
PTP is what's underlying from a synchronization perspective, is what's used. And so the way it technically works is that you have an IP core, an IP block that gets synthesized and placed and routed into an FPGA. That's hardware timestamping and synchronization. And then on top of that, you can also increase the capabilities of your Ethernet by having also these TSN grade capabilities also in hardware. So that's how technically it works. Yeah, as Derek said, just look for NXP has been doing some nice demonstrators with their routers. There's also some endpoints which you may want to look at. The easiest way to merge that with hardware acceleration, as I said, is just look for AMD solutions, at least in my experience.
I think that's a good starting point. So we are working more about like nanosecond range synchronization for software-defined radios on FPGAs or cameras and multiple sensors. So I think like if you're like actually like going for the new like MCU for robotics, probably, I mean, probably in the future at least, think about.
I mean, not sure if the level you're looking for is something we will be able to achieve. It's a bit too early. I can tell you that I know that we produced results in the past of sub-microsecond, nanosecond level synchronization capabilities in a distributed manner. Distributed meaning over Ethernet. And we did that with PTP in an FPGA on top of TSN or under TSN. But it depends I mean, are you looking at how many nanoseconds?
So currently we have less than 25 nanoseconds accuracy in distributed system. I mean, in wireless system, that is. But I mean, it depends on the application. So we do a bunch of like distributed perception with cameras. So for that, sub-microsecond is good enough. But if we are doing like communication with radios, SDRs, then it depends on frequency. So I don't know. It's an open question. So.
I mean, it's a good one, though. I'm happy to advise. We can bring that offline. I can share with you my experiences, and we can see if there's a way I can suggest. Cool.
That's great. Thanks, Mike.
All right, is Han? I think you raised your hand. Go for it. Or not. Okay, I'm gonna take this last one. Question: have you looked into to see I don't know how to pronounce it, SYCL as an option for the acceleration stack? So I did get this question in the past when we started the hardware acceleration working group. Was ages ago. I think someone from Intel brought this question. Here it was. Yeah, exactly in that thread. So in a nutshell, and to try to be as brief as possible, within the ROS2 hardware acceleration working group, we're trying to stay aside from the hardware acceleration framework design decisions, and more specifically, I can answer that by giving you a graphical depiction. So this architecture stack does represent the fact that we are extending within the ROS2 hardware acceleration working group capabilities. We are extending the ROS2 build system with essentially connectors and CMake macros at the end of the day that allow you to connect the various frameworks for hardware acceleration. Call it SYCL, call it HLS, call it CUDA, call it I don't know, whatever, ROCm from AMD. So you can use whatever framework and tooling you are leveraging, and separate that, separate concerns from what concerns building ROS2 systems. So we are focusing on building ROS2 nodes, ROS2 computational graphs, and then you can use whatever abstraction, whatever framework you want to build your accelerators. But that is your duty. We don't simplify the process of building those accelerators for you. That is your job to produce your accelerators using the tools you do want. So answering, have we looked into it? Yes, I looked shortly at what it was and how to enable it. I did not develop a series of CMake macros to prototype it, but I think that would be a fantastic contribution if you want to start working in that direction. And I certainly would be happy to guide you on that. I just don't have the bandwidth right now. And frankly speaking, we're trying to stick with what most folks out there are using, which narrows down to CUDA and HLS, of course, and also some other alternatives. But we're just sticking to that. I'm excited to see more opportunities and capabilities, but yeah, we'll need a bit of support to enable them. Okay, so we've reached the top of the hour, guys and girls. Thank you so much for participating. It's been an exciting meeting. Lots of work that was announced for us. So happy to see so many people sticking until the very end. Thank you once again. Also, thank you to Max for sharing his time with us, and also for the collaboration. We'll be looking into this very exciting Robotics MCU project.
Thanks for the invitation.
Very, very pleased to do so. And yeah, folks, we'll meet every month as we've been doing. And next meeting, you can expect it end of October-ish, but I will confirm in this course, as always and as usual. The caveat this time is that ROSCon is going to be also kind of like at the end of October. So I just want to make sure to be mindful of people coming back to their homes and countries and so on and so forth. But anyhow, in principle, we'll meet in a month. We'll report on the progress. And other than that, thank you for your time. Thank you for your interest in hardware acceleration. And stay tuned to upcoming meetings. Thank you so much. Ciao, ciao, everyone.